So now in this video, we're coming back to this circuit, but I improved it. I made a recent video. It's already uploaded and everything. It'll go live at some point. But in any case, we have this circuit here that's kind of meant to help protect a lithium-ion battery if that's what we were using to power this circuit. We're simulating it with the power supply there. So this LED module can work up to 5 volts right there. We got the LED module plus the other circuitry current. And also, this is a little bit more voltage than I probably should use, but should still be safe. So in any case, there we go. We got 4.2. Now, my goal was to get as close to 0 milliamps of current at 3 volts as possible. That's kind of when you want to stop using a lithium-ion battery. And, okay, we got a little more current than I did when I was testing. But in any case, there we go. We got 3 volts. Now, when I used this Schottky diode in the previous video, we had more current. I think it was about 17 milliamps of current. This is not as accurate as a multimeter, and if we kind of bump things wrong, it might go up or down 1 or 2 milliamps. But in any case, you know, you can see we got about 4 right there. We definitely want 0 by 2.5 volts. So, but there you can see 2.9. We're already, I think we're just borderline 1 milliamp of current, according to this power supply. Of course, a multimeter would be more accurate. And so we probably got a whole less right there. The LED does still have a slight glow, as you can see there. If I go to 2.6, then there should still be a slight glow from my earlier testing. And there we go. We do still have a little bit of a glow. I didn't think so when I had the lamp on. It looks like it's off completely. So a little current's like trickling through. We got a little bit of light, but you know, it's practically nothing. We should be okay, at least for quite a while, with the lithium-ion battery powering this from it over discharging. So now let's get back up to, I think it was 2.9 when we stopped, you know, we're showing any number at all. I'll go to 3. And so what I'm going to do is I'm going to swap out the Schottky diode that I got right there. So it's forward bias, 1N6263. So it should have a forward bias of about the same as, I forget this, it's SQ, I think, yeah, 15 SQ and then 045, I believe. So you can use it to block up to 45 volts, and it can handle up to 15 amps of current. That's why the wires are so big. You know, that'd be maximum for both of those. But in any case, I just, you know, it's bigger. The leads are bigger than what will fit in the board. So I stuck it into this little screw down terminal there, which does fit into the board. So we won't want to use 15 amps, not even close to that, like this, but we can do that for the small circuit. So yeah, at 3 volts, what did we have? I think we had like 4 milliamps of current, and now we got like 8, and I think we got less than we did in the previous video. But in any case, there you can see it's also going down rapidly, but we were at, you know, showing 0 milliamps of current by that point with the other Schottky diode right there. So the particular diode that you use matters. This is not, I don't think, a terribly good circuit for this Schottky diode, but much better for that one right there. As I said before, the 1N6263. So, you know, since the larger one, you know, I didn't put a part number right there, I should have. Since the larger one didn't work as good, you know, that's not the circuit I would use. I would use the one that I just showed you, the packaging right there. It looks like it builds up a little bit more voltage at these low currents. We could test it at like different currents and stuff. But we're just going to look at this particular setup today. You know, if you're not getting the results that I show you in a circuit, especially if you're not using the exact same components as me, that may be why. You know, different part numbers will probably have like slightly different forward voltages at different current and stuff. So it's forward bias like the LED. It's in the direction to conduct right there, but it drops less voltage than a regular rectifier diode, which is going to be about 0.7 volts. It's going to be closer to 0.3 volts there, but at lower voltages it's going to drop less voltage. But you know, if this complete circuit is unfamiliar with you, we have the NPN bipolar junction transistor right there. when we get enough base to emitter current, then it'll allow many times that amount of current to flow through collector to emitter. You know, maybe 100 times, maybe 200 times or something. But at these higher currents, it might not be as high of a multiplier. So you want a fair amount of current base to emitter right there. And again, you'll get many times there. Also, as the voltage goes down, there's just less voltage across the LED, so it's going to get less bright. This isn't really controlling the LED brightness. Mostly, it's controlling whether it's on or off at all, because it's going to go down as the voltage goes down. So is that one, because there's less current and so on. But at some point, the LED module will want to conduct more than what the transistor allows. So will allow. So I can just pluck the transistor. Now there's nothing passing current, and I can just pass current through this module right there, and you can see we got about 20 milliamps of current instead of, I think it was like 2 before. So if we were using a battery, you know, now it's still kind of draining the battery a bit, but with the transistor, it's almost not draining the battery at all. So not perfectly off, you know, but relatively close. And that one was with the emitter to the left. There we go. So make sure I put it in the right way. That was with the Schottky diode. So 9. So yeah, we got like 50% protection with that one when it comes to discharging the battery by accident. And with the smaller Schottky right there, again, part number 1N6263, and I didn't realize they were open. They started pouring out. And I got it from the Joe Knows Electronic Semiconductor Kit, which I recommend getting after you get the basic components. So you can like just get your diodes from that kit if you don't happen to have any diodes at all. That's not where I got these larger ones though. This is my only Schottky diodes, these smaller ones. But they have all kinds of other diodes and transistors and stuff. And so they have the 2N3904 and the 2N3906, which I use in many other videos. But I would not use for this particular circuit when it comes to switching the 5 volt 1 watt LED. Means you get 200 milliamps of current when you got 5 volts across it, but we're only working with 4.2 volts in this video. And so, you know, 5 volts will get you about 200 milliamps current. 2N2222 can switch up to 600 milliamps of current. You know, that would be maximum, but you know, we got about a third of that we're switching here. Whereas the 2N3904, you know, kind of the same as the 2N22, but it can't switch as much current. Apparently it can switch faster. If you gotta switch faster, like really fast, you'd rather use the 2N3904. But when you're switching, you know, a little bit higher amount of current, you'd want to use the 2N2222 over the 2N3904. So in any case, yeah, that's really about it. And I kind of assume you know like a fair amount by this point if you're watching this video. If not, you know, learn about how transistors work, the forward voltages of stuff. We're using the forward voltage of the LED, somewhere about 2.5 volts at lower current, you know, 3 volts at higher current. Schottky diode is going to be, you know, about 0.3 volts, but, you know, it can drop down to, you know, around 2 volts, or 0.2 volts, I mean, in that range at lower currents. And then the base to emitter again. It's about 0.6, 0.7 volts, but you know, it might trickle down to about 0.5 volts at very low current. That may be possible. And therefore, these are going to drop the voltages, but again, they drop less at lower current. But in any case, that voltage that's left over will go across the resistor, and it will set the current. So it's almost nothing when you get down to like 3 volts. Very close. But you do get that multiple amount going through the transistor right there. So, you know, there's all kinds of adjustments you can make to this. It's not perfect either. There's better ways to do this, but if, you know, you should already have a bunch of transistors, and, you know, if you happen to have Schottky diodes right there, that's 2 components that don't really cost much. And so this is a simple way that you could help prolong the life of a lithium-ion battery if you might not be able to attend it constantly, where you can remove the load as soon as it's getting close to its minimum voltage. So, in any case, all stuff to review in more detail if none of that made sense, but otherwise, I hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.